Solving quadratic equations by completing the square. Quadratic equations can be written in another form by completing the square. If we've got x squared plus bx, this is the same as x plus b over 2 all squared minus b over 2 squared. Let's think over that for a second. When we times that first bracket, x plus b over 2 squared, that's x plus b over 2 times x plus b over 2. So we get x squared plus 2 lots of x times b over 2, i.e. that's the bx, plus a b over 2 all squared that we don't want. So that's why we have the minus b over 2 squared on the end of that. B over 2 is half the coefficient of x. If we see this as an example, x squared plus 8x, that's the same as x plus 4 squared minus 4 squared. And if you work through the numbers, x plus 4 squared is x squared plus 8x plus 16. So there's a plus 16 we don't want because our original expression was just x squared plus 8x. That's why we have the minus 4 squared on the end to get rid of that 16. So x squared plus 8x is equal to x plus 4 squared minus 4 squared. Let's check again. X squared plus 8x plus 16 minus 4 squared is x squared plus 8x. That's completing the square. X squared plus 12x. All you have to say to yourself when answering these questions is, what's half of 12? 6. So it's x plus 6 squared minus 6 squared. X plus 6 squared minus 36. X squared plus 3x. All you have to say to yourself to complete the square is, what's half of 3? 3 over 2. So it's x plus 1.5 squared minus 1.5 squared. I'd rather see it as x plus 3 over 2 squared minus 3 over 2 squared. How about 2x squared plus 10x? Well, slightly different now. There's a 2 at the start. There's a 2 coefficient on the x squared term. When we're faced with anything that isn't simple 1x squared, we need to turn it into that form. In this case, there's a common factor of 2. So we can whip the 2 outside to be 2x squared plus 5x. And x squared plus 5x is something we can complete the square on. Half of 5 is 5 over 2, or 2.5, so it's x plus 5 over 2 squared minus 5 over 2 squared. But we can only complete the square when we have 1 as the coefficient of the x squared term. We can tidy that up a small amount to say that's 2 x plus 5 over 2 squared minus 25 over 4. And then we can times the 2 through to be 2 x plus 5 over 2 squared minus 25 over 2. We can use the idea of completing the square to solve quadratic equations. This is a very good way of solving them. There's not much sums to do, and in C1, which is a non-calculator exam, the fact that the whole thing can be done using surds if necessary means that it's an ideal way to solve quadratics that can't be factorised and for which the quadratic formula that we'll see in the next video is just too much like hard work. So, complete the following by completing the square. X squared plus 8x plus 10 equals 0. Our first step is to rearrange it to get the x's on one side and any numbers on the other. So x squared plus 8x equals minus 10. The second step is then to complete the square. So half of 8 is 4, so it's x plus 4 squared minus 4 squared equals minus 10. The third step is to rearrange it into the form we saw in video 8 when we were solving quadratic equations through factorisation. If we add 16 onto each side, we end up with x plus 4 squared is equal to minus 10 plus 16, or x plus 4 squared is equal to 6. We can now solve that because if we square root both sides, then x plus 4 is plus or minus the square root of 6. And then we can solve both of those equations, which is either going to be x is minus 4 plus root 6, or x is minus 4 minus root 6. Another example, 2x squared minus 8x plus 7 is equal to 0. Well, first step, let's divide by 2 so we can have it in a form where we can complete the square. X squared minus 4x plus 7 over 2 is equal to 0. Now let's rearrange it. X squared minus 4x is minus 7 over 2. Now we can complete the square. Half of minus 4 is minus 2, so it's x minus 2 squared minus minus 2 squared. That's the same as x minus 2 squared minus 4 is equal to minus 7 over 2. So if we add the 4 on, we get minus 7 over 2 plus 4 is a half. So x minus 2 squared is equal to a half. We can then square root both sides. X minus 2 is plus or minus the square root of a half. Finally, we can add the 2 on to say that x is equal to 2 plus or minus the square root of a half, or 1 over root 2, if we remember our rules of surds from much earlier.